I'd like to introduce Professor Jain. He will be speaking on common issues, AI and security. So Professor Jain, as I told you, have been collaborating recently on real big ways, but I have known him as a professor, as an entrepreneur, in many ways. So just to introduce him formally, he's currently the Barbara J. and Jerome Cox Junior Professor in Computer Science Engineering at Washington University, St. Louis. He's a life fellow of IEEE, fellow of ACM, and also fellow of AAAS, which is the academic science. He's a recipient of 2017 ACM SICOM Lifetime Achievement Award, which is pretty well-known and prestigious. Previously, he was co-founders of Nana Networks and senior consulting engineer at Digital Equipment Corporation in Massachusetts. And after that, he was a professor at Computer and Information Science at Ohio State in Columbus, Ohio. He has research is very much related to industry. As a faculty member, he actively participates in industry forums like MyMax Forum, many IEEE standards activities, and ITF, where I actually first met him. He has made over 200 contributions that ensure that research and implemented, not just published as papers. I can see that by collaborating with him in the recent past. He also been a big contributor in IEEE standards, as you can see, 230 plus. And he was awarded in 1999 Silicon India Leadership Awards for Excellence, Promise in Business and Technology. Has 14 patents, written 18 book chapters and 90 plus journal magazine papers, and 130 plus conference papers. His papers have been widely referenced. He's known for his development analysis of congestion control avoidance, traffic modeling, performance analysis, error analysis, and with more than 38,000 citations. So with that, I'd like to invite Professor Jain and spending valuable time and enlightening us with your talk on AI cybersecurity. Professor Jain.
Thank you, Asutosh, for that big introduction. I had sent you 3 lines. I don't know where you found 30 lines there, but anyway, thank you all. So this talk is about what are the issues that I have seen in my own work on AI. We have been using AI for, I haven't forgot time, maybe 4 or 5 years, and we are experts in cybersecurity, so we have been using it for cybersecurity. Now, all these slides are available online at this QR code. So you can either remember the QR code, you can click it right now, the slides are there, video will be there, at some point, and or you can remember this URL which says AI Sec AB. AB is for ACM Baltimore. And then this URL will be at every slide, and so you can just remember at any time and download it. And that's with that, let's begin. So here is the QR code I mentioned. You can scan with your phone, and the slides will be there on your phone. And so this slide, this presentation has 3 parts: AI, where it was, where it is, and where it is going. And then our own research, just 2 slides. And then the lessons learned. So the main part is the lessons learned. I kind of felt that there are many mistakes that we have made and other people are making at the same time with AI. What are the issues? And that gives us challenges, and the challenges give us, what we should be doing. And that's what we always look for, is what research can we do? All right. So before AI, we were all into the smart things. And the smart things, basically IoT, all the IoT, when it came, they're things. And then basically they became smart because they were connected to the internet. Anything that is connected to the internet has direct access to Google and can get information around or answers very fast, faster than what you can do in the library. And with internet connection, you don't have to be anywhere in particular. You could be anywhere you want it to be. So now everything is smart actually today. The watches are smart, the health is smart, the cities are smart, and the home is smart. But that is past. This is old news. What is new is that now everything is trying to become intelligent. So we are now no longer interested in a smart camera We are interested in an intelligent camera that can recognize my face, that can recognize my voice, that can, allow me to do whatever I want to do and not allow somebody else to do what they want to do, right? So now AI has become reality and things are becoming intelligent. That means intelligent means basically with AI, and they can do things which our 5 senses can do, which is touch, see, hear. Smell and taste are still difficult, but they would be coming. And many of these may be called AI or may be called pattern recognition. So maybe, they really don't use that much of intelligence. They might be just very high level, very high quality pattern recognition. And so nowadays, when I call Fidelity, which is basically has all my life savings, they recognize me from my voice print. Similarly, other financial companies have moved on to voice print, and I don't have to tell them all the data, this and that. And then, of course, the touch ID, facial recognition on your phones, and even driving car, basically, everything is with AI. So intelligence is here. And so AI is everywhere in my home, basically, because I try to keep ahead just to learn everything what is going on in the real world. Most of the things are intelligent today, okay? So the coffee machines, vacuums, robots, driving. Now, I don't have a self-driving car, but people are coming up with self-driving networks, which means that a network which you don't need to program, you don't have to debug, you don't have to do anything, it does it by itself. And then, of course, the planes have been on the autopilot for a long time, but that was not really AI. Now, I think with AI, they can do a lot more. And the first, it will come in the military, where the drones are coming with AI, right? So what is coming is now edge intelligence. So today, if you're doing research, you're probably working on edge intelligence, not on the core intelligence, because everything is coming to the edge. And the problem with bringing AI to the edge is that it requires a lot of computation. It requires a lot of power. And the answer for that is that companies like Google and NVIDIA, they have all come up with their own computers that can do AI right in a palm-sized device, right? So basically, we have AI like this one. You can buy it on Amazon, and we have several of these for $99 to $199. And then you can put AI in any device where you want it and any place you want it, right? The main thing on this board is that heat sink. Everything else is very small. The heat sink cannot be made small. That's basically the bottleneck there. And then the cost is coming low and low, and then there's a lot of competition in that space. So then what else is coming? So there are many things coming. First is the distributed AI. And distributed AI, because it requires a lot of power, so people are obviously going to distribute it. And edge intelligence is actually one form of distributed AI, where you do some computation at the edge and most of it, and then send it to the core where some other parts are done. Transformers are basically for the languages and translations to transform from one language to another, and composite AI, basically both existing technique and machine learning. So what it is one should realize that machine learning is just statistics, very sophisticated statistics. It is statistics at a level that you don't understand. Basically, if you understand, then it is statistics. If you don't understand, if you can't do it in your head, you cannot do it on paper, then it is AI, right? So that's what it is. But there are cases, and I will show you many, where existing techniques and machine learning, knowing both helps. Human-centered AI, and now basically what is happening is the AI is being put everywhere, and so at many places we lose the touch, and so we have to put a human in the loop so that wherever the machine loses the touch, we can fix it. And then the machines are becoming like humans. They are unfair, they are biased, they're, and so on and so forth. So we need to develop AI that is fair and unbiased and so on and so forth. Right? So there is a lot of work required to be being done there actually. Generative ideas. Now this is the next generation of AI where it will generate new ideas, new methods, new knowledge. So right now, I mean, like most of the AI that we use, it does generate new knowledge, but basically it generally only generates whatever I know, and then I ask the AI to do the same thing. And so, but really, can AI think itself? Can it just, go from college to from high school to college by itself? That is coming up. Then basically this TRISM is again like human being. Can we trust it? Can we take the risk? Can we do security management and so on? And the final word is general intelligence, which is almost like human. And right now, according to DARPA and other places, I've heard that AI today is like 18-month-old child. That's how much it can learn as 18 months old. So they're not very much smart. So there's a long way to go. But that way will come fast because the artificial intelligence is a good area to be in. You can publish very fast. I mean, we have published a lot of papers because we are working on AI. And then, you can generate artificial knowledge very fast, lots of papers and lots of research funding. AI Institute, $20 million, each institute, and there are tons of them. And in 2019, when the news media reported that China is ahead of US in AI research, and I remember that news item because I saw it myself too, suddenly the government woke up and they started this AI initiative, and now billions of dollars are available today. European Framework Program was first to fund IoT research. So I was also following before as well. In 2010, I wrote a paper in which I said that, these Europeans are working on something called Internet of Things. I mean, Internet of Things. We were not working on it. US NSF was not working on it. And at that time, that paper was the next step for NSF or something like that, Anyway, so they were first to fund IoT, and now IoT is everywhere. So basically, I mean, this is not a time to complain. It's just to say that this is a big opportunity right now, and the big opportunity right here in the United States. There is plenty of funding from NSF, and so everybody is working on it. So what we are doing? So we started with AI-based security of IoT. All right. And the first thing, basically, even though before that security we have been doing for a long time, and then 2017 we started in AI 5 years ago, and then first thing we did was IIoT, Industrial Internet of Things. Okay, and then we got into medical IOMT, and so Internet of Medical Things. And this is the project that I am basically collaborating with Asutosh, as you mentioned. And then we use everything that is available today for security, and that includes blockchain. So blockchain and AI are the two main tools for me to do security of things that we know. And we have lots of papers. The list of the papers is in this presentation, which you can download. And then, so we apply not only the AI, but also whatever else is there around it to the problems that we have. All right. So 2 slides, one on the IIoT, which is the industrial control systems. So we actually put a test bed in our lab to develop the data, to generate the data, and to see how we can attack it and how we can protect it and all that. So this slide shows that. And in fact, our data is public. It is called Gustal IIoT 21 data set. And it is available right here at this URL. If you click there, you can download a few megabytes of data, and you can apply your own techniques to it. The second thing that we did was on the medical things. So we set up a test bed, and my students would put all the sensors, medical sensors, blood pressure sensor, oxygen sensors, and whatever else we could find on their bodies, and then, try to attack, and so on and so forth, the same thing as an IIoT. And this database is also available. This data set is also available on our website called Gustal EHMS data set. and medical systems, enhanced medical systems, something like that. And then it is available at this URL. And I mentioned the word edge AI before. And of course, before we mention anything in public, we got to have done this already, right? So we did this back some time ago. And so we started with edge AI, and we have a paper now, which just came in, paper on hierarchical deep learning. So basically what we do is you can do, when you get anything, and this was actually done for medical systems. So when you get something, it goes to the edge cloud. Now the edge cloud does not have to be on the tower, but it could be very well be on the tower. It could be just on your phone, okay? And so we do analysis of that data and then just send the summary to the core cloud. And we found by doing this method, we save a lot of traffic and we get a lot better result in terms of accuracy. And then of course we have saved a lot of money because now the power here is not that expensive. And the power here is also less expensive because we are not using that big a deal, right? So this is also known as federated learning and distributed learning and all of that. And so this is now published. And so we are moving to other things. So there are 9 problems that I am going to talk about today. While doing our research, we found out that there are few things that are wrong with the current AI. First is, and the list is here, and I will go through them one by one, so there is no point in making the list right now. I just want to show you that we will start with number 1 and go to number 9, and then see what should we be doing. First of all, no domain expertise. Basically, people are applying AI to anything they can find the data of, and that's all. And that produces a paper. Really. I mean, you can take our data set and do something, and then you publish a paper, you have a paper. And so, as they say on the internet, you never know whether it is a doctor or a dog. Everybody sounds like the same thing, right? So, machine learning algorithms are used without domain expertise. However, domain expertise is very smart, very important. I mean, can you imagine that the machines can basically do without the domain expertise? For example, and I will give you a networking example because we are all networking people here, hopefully, are computer science people rather than doctors. What is the distance between port 80, port 81, and port 8080? The numbers are very different, but the distance is 0. Because all of them are simply saying that we are going to a web site, right? This is HTTP protocol, all 3. And so this can become only if you know HTTP protocol, at least you've taken the first lesson in HTTP or first lesson in web or first lesson in computer science or something, right? And so other people probably would think that these are very different things, 80 to 8080. And similarly, cleanliness, labeling, feature extractions all require domain knowledge. Okay, but it will be very difficult for you to find a paper, published paper, where the domain people are present. And I'm not saying that we are not expert, we are not guilty of the same crimes, right? But I'm just bringing it out that these crimes are being committed where we have the results about everything, and people, we don't know anything actually, basically. That's the thing is that, you know, and the problem is this. When we started this IIoT project, IIoT, industrial control of thing, the sponsor required an industry to be partner. And we said, okay, all right, we found an industry. They said, we will partner with you. And when the money came in, and then we said, okay, let's work on this. Let's apply our technique to your data or share your data with us. They said, sorry, we cannot let you come into our company. We cannot share our data with you. It's all confidential. So nobody in the academic world has access to the real data. And that's the problem. Maybe it is the academic problem. Maybe the company itself can apply AI techniques to their data because they have their data, but we don't. All right. And so we end up doing simulations of actually test beds, small test beds like this, which is basically what the academics can do. Now, Google has all the data of the world, and they're also gurus in AI. So they can analyze the real data and they can come up with the real knowledge, and they can do whatever they want to do with that knowledge, mostly make money because they analyze every word I'm saying, and they're going to give me an advertisement or everything that I said. Maybe I will get an advertisement for intelligent camera. Who knows, right? So those people, the big companies, do have, and they're making good use of the data set, but we don't have the data set. Actually, I probably moved on to the next slide, which was random data sets. And this is a cartoon just to keep you awake. So it says, I need some data from an unreachable guy named Ed. What should I do? So the answer is just make up a bunch of data like everyone else does. Well, everyone else does that. Is that really? Yeah. Are you doubting my data? So this is his data. But this is truth. This is truth. We academics have no access to anything real in the world. Okay? And the real world does not want to share anything with us. All right? Because we are open source, we are open, and so on and so forth. So who will want to share with you, right? And so that is the situation. So what happens is real data is private, it is not published. Published data is either too old or too generic. All right. I can tell you, you can find at least hundreds of studies which have used KDD cup data, KDD data set. KDD was done in 1999, 23-year-old. We have done it too, by the way. And 23-year-old data, and this is not a real data still. This was a data set which was designed for a competition called KDD cup. All right. And people use data sets like these for whatever their problem is, and you get a garbage in, and the results come out is garbage out. Right? So you cannot really say that, okay, we solved this problem. I mean, IoT security or whatever that is, you know that now you know machine learning. Probably you learn machine learning so you can put a data set and come out with a conclusion. You will get a job. When you get a job in the industry, maybe you will be able to use the real data set and get with the real answers. That's all we can hope, because the real data set is not shared and not available. Third, now this is not as well known, but one of the things that we learned about security is that the security and our data is very, very, very imbalanced. All right. AI started with graphical, with images, and they could identify a dog from a cat and things like that. But dog from a cat are so basically the data set is very balanced. The number of zeros is equal to the number of ones. Okay. The number of bits is very evenly distributed. But this is not the case in security. I went to my university and said, hey, we are doing research on security. Can you please share your traffic data with us? They said, yeah, sure, Professor Jain, we will be happy to share that with you. And they said, but here's the thing though, the data is about 4 trillion bytes. And I said, that's no problem. I have terabyte disk. But then they said, maybe there are 3 or 4 attacks in there. Okay, so that is the imbalance. To learn those 3 or 4 attacks, I have to analyze 1 trillion or 4 trillions of non-attack data sets, non-attack data traffic, and then I will learn that, okay, what attack looks like, right? And the machines are not that smart yet, okay? Basically, they really need some good number of examples to do that. And so how do we do that? Well, basically, there are techniques where you just generate more of the attack data from whatever you have. So from 100, you can generate maybe 2,000, maybe 2 million. But again, you lost the real world right there, right? And so the thing is, in most papers, 10 to 15% of the packets are attack packets. Now, if you lived in a world where 1% of the packet was an attack packet, this is what it looks like, Syria. Okay? And so you cannot live in a world where even 0.0001% of the packets are attack packets. We talk about security attacks every day in the newspaper, but we don't realize that every day, multi-trillions of bytes of information which is not attacked also goes through, right? So it looks like attack is everywhere, but it is nowhere. Really, to learn, you really need a lot more balanced data, and that balance in most of these studies is actually a mirage, in the sense that they just create it, and so this is one problem. So we studied that little bit. We showed the effect rather than solution of imbalanced data sets. We showed that how the result could be totally wrong, and by using this technique where you create more attacks from some attacks. The next problem is wrong metrics. So when AI was invented, it was to distinguish a dog from a cat. And it was very easy because 50% of the bits are 0 and 50% of the bits are 1. And if you want to find out how good AI is, you figure out how many zeros were predicted as 1 and how many ones are predicted as zeros. And so the most common metric today is called accuracy, which is true, positive, and plus this, that. You can divide that by basically what you're doing is you can find out percentages of the wrong answers. All right. And if you are near 1 or 2%, you are doing very good, right? But security is not like that. All right. If you are wrong 1% of the time, just imagine. So I will give you an example. Iran, I don't know Iran, but basically 5 missiles hit Iraq, US troop base, US base in Iraq. 5 missiles hit. Now, I'm sure if we were AI guys, we could have predicted some of them, but if they're 5%, we are 1% of the time wrong, which means if they send 100 missiles, we will miss 1. Would you live in that city? Right? So again, what we need is 6 nines or 5 nines, which means 99.99999% accuracy, not 50%, not 1%, not 2%. And I haven't seen a paper yet which shows me a security paper which says that we predicted to 10⁻⁻⁶ accuracy. I mean, just subtract them from 1 and that would be accuracy. 10⁻⁶ inaccuracy. All right. And we found that accuracy is really not an appropriate metrics to compare one AI techniques with the other. And so we invented our own. So we have a new metric which was published actually again in IEEE networking letters. We call it a safety score. And safety score is basically what it is we are imbalancing the accuracy because our problem is imbalanced. In our problem, one mistake can cost trillions of dollars. So we really have to charge trillions of dollars if you made that kind of mistake, where there was an attack and you didn't tell me. Right? While if there was no attack and you said, well, there is going to be an attack and nothing happens tomorrow, all right, which happens every day in my weather forecast, so nothing happens, then I still have to prepare for it. There is a cost, but it is much, much, much smaller compared to the cost of not being prepared for it and suddenly the hurricane hits my house, right? And so the costs are very different than the original AI or with other AI applications. For cybersecurity, we have to have a metric which really tells you about based upon the cost of the 2 kinds of errors that we are talking about, right? And that is the safety score. All right. Now, when you do AI, because AI is done by machines, we have a tendency to put everything into the pot and make a mixture. The AI will figure out what is good, what is important, what is not important. When we had to do analysis manually, and I have been, by the way, I am a statistics person. I wrote a book on statistics called The Art of Computer System Performance Analysis back in 91. So the idea is that when we have to do these things manually, we generally select one or two most important factors, and we say, okay, all right, let's try to do with these two and see what we come up with. But here now, basically what we do is we collect everything, put into the pot, and then machine figures out well what it is. If you selected a lot of factors, then of course it will take 5 days. So you don't have that much. So you say, okay, all right, we are going to reduce the number of, and they call it features, by the way. We are going to reduce the number of features, and there are techniques for reducing number of features. And really the statistics, I mean, people who are doing AI, if they're not statistically literate, they are going to make a lot of mistakes because it is just sophisticated statistics. And if you didn't learn the basics of statistics and you started doing AI, you're going to end up where the features are very correlated. And then, we learned that in ABC of statistics that using two correlated predictors will get you into more trouble than one predictor, right? And so feature engineering can help you figure out maybe correlation, but they cannot help figure out what is a missing feature. A machine cannot say, hey, you didn't measure this thing, but that is most important. That doesn't exist yet in AI, right? So you got to really think yourself as to what is it that is critical, important, and that is where you need the domain expertise. And that is sort of missing from many of the papers here. And finally, artificial intelligence is something that we cannot figure out what it is doing. All right. So if I feed all my data into a machine and it comes out, Raj, you have a heart, you have a cancer, let's say. Let's make it a little bit more interesting. Cancer. Would I run for my chemotherapy? I would not believe that, right? And that is what is happening. Basically, any prediction given by AI cannot be trusted because we cannot understand why it said that. Most important thing is why. In the manual world, we started with why and then we went to what. Here we come to what without knowing the why, right? So machine learning is what only machines can do, but human cannot do and cannot explain, right? Because, well, my model said that I applied ANN and the ANN said that, you have cancer. Big deal. So the idea is that AI is a black box, and we really want to make a transparent box. Some people want to call it a white box. Whatever, we want to make it a transparent box so we can look inside and figure out why it said so. Right? So there is this work on explainable AI, and we delved into that. We wrote a paper. Is that basically explainable AI is to explain why it said so. Okay, and so this TrustX AI is actually, the concept is that we use two things. We use a smaller statistical model, and we use the machine learning model. And actually, our statistical model is trained by the machine learning model so that its results are very close to the machine learning model. And when machine learning model says something, we can explain with that small statistical model, look, there are these 4 things and this thing is high, your blood pressure was high, and then plus this thing was high, and therefore it looks like, you have wrong blood count and you have a cancer, right? And then people can believe it. But I just gave you a medical example. If I change that to cybersecurity as to why do you think that we will be hit by a missile tomorrow, that requires even a lot more explanation before anybody will put their trillions of dollars one way or the other, right? And so explainable AI is very important, and the work is being done on that. No sensitivity analysis. Now, some of these are actually, believe it or not, from my days as performance analyst, and this is one of them. When I was writing the book on performance analysis, in those days, and I was actually a performance analyst in the industry, a digital equipment corporation for 16 years. I found out that this was a common mistake, not only in the academic, but in the industry, because actually I was only in the industry, not in the academics at that time. And the problem is, if you say something, you have to really know how you are depending upon your assumption. If you assume something, if that assumption is not right, what the result would be. That is called sensitivity analysis. You move your assumption, you move your needle little bit plus and minus, and figure out whether this is going up all the time or is it really not going up except when you pass this threshold. Right? And so sensitivity analysis is important, but you cannot really do real good sensitivity analysis in AI, because in AI, you cannot just, in normal simulations, normal analysis, normal measurements, you just change one factor a little bit, and you can do the measurement again, you can do the simulation again, you can do the whatever theory again, right? And in my book, I said that you need to do two things minimum, not one. If you do a simulation, do an analysis or a measurement. If you do a measurement, do a simulation or an analysis, so on and so forth. What happens is, with one, you say whatever you want to say, with the other, you explain whatever you are saying is explainable, right? And validated. And then, so basically, proper experimental design was done. You could change, but here in AI, you don't have a choice, because either you use KDD dataset, or you use Wurstel dataset, or you use whatever other university dataset. Those are the only choices you have. You don't have a choice to change our dataset, one feature in that dataset. You can't change it. So you really have to jump dataset, the whole thing, and say, well, I tried on 15, and we have done that too. We tried on 15 datasets, and on 13 of those 15, this scheme is the best, and this is what the conclusion is. So you really have to do a whole bunch of things, a bunch of changes, and that really misses the whole sensitivity analysis point. You just know that data sets matter, and then the data sets matter a lot. Maybe you can say, well, it may matter 50%, whatever, but you cannot really go to the assumptions or features or sensitivity. Finally, eighth one, again, coming from the thing is that we always emphasized in our non-machine learning days that whatever results you publish, whatever results you come, please validate it. Please do the validation. And validation requires, again, one of the two things. Either you do go to the real world and figure it out, yeah, this same thing is happening. If somebody has these two things, then they have a cancer. Or you do a simulation at least, or you do a simulation. If you're doing simulation, then do this a corner measurement, not the measurement for the whole world, but at least some place where you can say, yeah, my model said this, and the real world also said this, at least on this point. And that is not done. With AI, that is not done because, what can you do? So there is a validation, by the way, done. What we do is we take the same data set and divide into two parts. We use one for training and one for testing. All right? If one is wrong, the other is wrong too. And then we say, yeah, based upon two wrongs, I told you this is the answer. This answer is right because it is based upon the same data set. One part was training, one part was testing. Right? And if you want to take it further, then you divide into 10 parts and take 9 parts for the training and 1 part for testing, and you keep rotating. And there are ways to do that too. But that's really not really validating in real sense, where you are validating a simulation with another simulation. You are validating a measurement with another measurement. I really think a better validation would be to go to the real world, go to another data, go to another place really, basically, which is totally independent. Not the same person generated data, not the same equipment generated data. Then you can make some results that are valid, right? But no validation is done. Testing in production. So that is one thing, is that, but some of these things apply more to academics than to industry. Industries have real data. Industries can do testing in production. They don't have to take the same data set and test it. They can collect all my data and say, well, all right, I predict that Jain is going to buy a refrigerator, and then they will show me all the advertisements, and then I will buy it. Then they say, well, all right, this passed. Now they will try it on you, right? And so they can really change the data set, or they change the person, or change whatever feature they want, and they can do testing in production. Google does it all the time, Amazon does all the time, and every other company, you name it, Facebook, they all do it all the time. They try something out and they try it in production, right? But we don't have that luxury. We don't even have a production, right? And so this is a problem, which is the no real world validation. Maybe we don't have the real world and therefore we don't have validation. Maybe this is an academic issue, but this is an issue. Omitting assumptions and limitations. So when you do an analysis, when you come up with a result with AI, again, this is missing one key feature of the normal analysis, which is that when we did the normal analysis, we listed a whole bunch of assumptions. We said, well, I don't think we didn't measure the temperature because we don't think temperature is important. We did not measure the wind speed. I don't think it makes a difference on the wireless speed, and on and on and on, hundreds of assumptions, right? With AI, you don't even know what the assumptions were made by the guy who made the data set, unless you make the data set yourself, which we did. And so the idea is that we don't know what the assumptions are, or what assumptions we are using for our analysis, and we just give the result, and we want to be proud of our result because we gave it to you, man. Come on, we gave you new knowledge. It is vital to describe the context in which the data was gathered so that the users will not use it in out of context. Okay? And that is very common because KDD data set, for example, is not for security. It is for something else, some other kind of anomaly, and people are using it for security. And I've seen other data set which have some other anomaly, but we don't care. We just need an anomaly, right? And that's why we come up with a technique which gives me 1% of error rate. But a security data set, you can't have 1% of error rate. And so that is the problem. Security data set assume specific attacks. The list of attacks in 2022 is very different from those just a few years ago, let alone 30 years ago. So we generated our own data set in, let's say, 2018. In 2018, we found out the most common attacks that were there, and we implemented them and we put them against our system. But if we were to do the same thing in 2022, new attacks have shown up, right? The data is no longer valid, right? But that is what is happening, is that basically the world is changing, and therefore something that really doesn't explain the underside, the inside of the whole thing, gives you knowledge that is only good for that particular thing. That's why we want this transparency in the AI. That's why we can't use that black box AI. Because we don't know really what is going on inside the black box and which feature of this is going to cause a problem, and whether this one attack will change the whole world. When then, if you have one attack which is not detected, again, I would be in the same trouble by missing one missile, right? So that is another thing, is that those are the limitations. So you say, well, this is valid until this time, and this is based upon these particular attacks. And if there are new attacks, then sorry, my results will not apply. All right, I think I'm coming to the end of my talk, and there is plenty of time for discussion. So hopefully you will have some questions ready for me. So what we have done is we have pointed out 9 problems. Okay, 9 problems with the AI today. And these are problems. Why we find out the problems? Because whenever I start working on any area, first thing we find out, what is the problem? Why people, what is it that we can solve so that something new will come out? And so this is the problem, right? And now this is not the exhaustive list, because this is my list and this is based upon my experiences. But there can be a bigger list, right? So each of these issues is a challenge. Basically, solving them is a challenge, and we took some of them. We took some of these challenges. We did our own research on those topics. We did our own papers on those topics. And since many of the people here in the audience are from the academics and are from the publishing world, they may want to work on similar things, is look at these issues and say, what can I do for this? So for example, we worked on the imbalance. We worked on random data set to an extent, actually, not really too fully because we don't have a real world data set, but we generated a data set that was for security attacks, security, and we created it, and we knew that at least what is inside it. And explainability we worked on, and so on and so forth, and we are continuing to work on other problems, right? So this is how we find out opportunities for research. And this is how you can find out opportunities for your own research. That brings me to the end of my talk and the 5 key messages. The 5 key messages are, first, AI is a prime topic for research. All right, this is very important. If you want money, AI is where the money is. Okay, AI is a prime topic of research, and that's what we do too. We look where the money is and we go there, and everybody does the same thing, right? Google does the same thing, and Apple does the same thing. So why not us, right? So this is a prime topic for research, especially for IoT and security. AI for security is very different from image-based application. This is one thing that you have to at least get from this talk, my talk, and we have experienced it at every step of AI, that it is not your normal sense-based AI, whether they were talking about the touch or they're talking about the face, they're talking about this, whatever it is, images. Those are much easier problems. Security is a problem that requires a lot more work. AI results will not be trusted without explainability. And this is especially true for security issues. Anything that is very dangerous, anything that can result in a very dangerous world if it was wrong, that requires trustability. Okay, and we worked on that and came up with some ideas there. Extreme risk and security application requires newer metrics. The metrics that people were using, the metrics that we used before, we found they were not really representative of what is going on in the security world. And so we proposed safety score. And intelligence is moving to the edge. So that is the 5th message. Intelligence is moving to the edge. And actually, I forgot to mention that, but most of those 2 test beds that we had, in particular, at least on the medical test bed, we use those edge computers, basically those devices that can do AI in the edge. And that's very helpful because the iPhone are actually, in general, smartphones are almost getting to a point where they can do simple AI. And then we are hoping that the carriers will install some computing power on the 5G towers where we will have edge clouds. And so I think that will make it even better. And so the idea is you don't want to send the whole billions of bytes to the core cloud. You really want to do as much analysis as possible. And then we showed the feasibility of that with our own hierarchical AI paper. So we have actually a paper on almost all of these. And so that is towards the end of that. And so here are our papers. I'm not going to read them. You can download the slides again from here. Like I said, AI Sec AB, AI Security, ACM Baltimore, right? AB. And then continued AI, ICS security, healthcare security, and blockchains. Now, I haven't talked about the blockchains at all, and I don't have time. I could probably. But the thing is, blockchains are another new thing that is coming up, although it is much more popular in the banking world, financial world, and supply chains. But there are lots of applications of it in networking as well. And we are working on those, and security as well. All right, that brings me to the last slide, which is again the QR code. If you found anything interesting, and you wanted to see it in detail, you could just scan this QR code. If you don't have a scanner, just take a picture of this slide, either on your computer or on your phone, and then you can scan that picture later on, or you can just remember this AI SecCab tiny URL, or you can remember this, which is my website, and then AI Sec AB. All right. I think we have 10 minutes left. So I would really welcome if people would ask questions about what I have said, your disagreements, agreements, or anything, any kind of feedback.
This is Narsimhan. I have a question. I don't know who is moderating, so please let me know if I can ask
You can
questions.
just speak. Right now, yeah, all right. But right now you speak. When it becomes impossible, then we will have to put some order into it.
Professor Jain, I know you from School Automation. It is an excellent talk.
That was about 50 years ago.
I know.
Information.
It is amazing. Your knowledge about performance and other things, I was appreciated. But now you have really given a very broad view of AI and what their challenges are. And I think the next generation should try to address those problems that are there. And especially, and I have a few questions as we go along, and it is a very commendable talk today, giving a broad perspective of AI. And it is, I think, something which is missed in the real industry. And people are applying this to 5G, 6G, and so many other places without knowing what exactly is required from AI. So I think you have hit the point, because I used to do work on PhD in pattern recognition AI. I worked on it, but I think you gave an excellent talk today. And I have a few questions.
Narsimhan, what is your question? Sorry.
Yeah, I think one of the things you talked about is IoT and medical applications. There, the main problem is in security is they giving you the data that you require, but unfortunately, the privacy requirements in each country is so different. In fact, in Europe, it is even more restricted than in the United States. And I was wondering how you are going to deal with those kinds of issues, which are regulations, which has nothing to do with actually applying those data to the AI algorithms that you probably have proposed.
Yeah, right. So I mean, basically, I talked about the not availability of data. And so when we started working on the AI medical applications, we had a hospital working with us. They wrote out their name on the proposal. And when the time came, actually, there were two problems. When the time came, they were still very collaborative. They said, okay, all right, here is our equipment. You can do whatever you want. But the problem was that equipment was made by, let's say, company X and let me name the country Y. And this was, I mean, I don't remember which European country made that equipment. And that company will not share anything about their equipment, because they knew that if the professors started analyzing their security, they would be in big trouble worldwide.
Mm-hmm.
So basically the way it worked was, and this is how our own data works, by the way, is that when you go to a hospital, you are using equipment which is coming from some part of the world which you don't know. The data is actually sent to the company, to the equipment manufacturer. All your camera data goes to the company that you bought the camera from, whether it is Amazon, Arlo, or whatever you bought the camera from.
Mm-hmm.
That is where the data goes, right? And same is true for medical applications. All the data goes to that country, that company, and that place.
Oh,
and
boy.
Where is the security? Where is the privacy? Nothing.
I think we need
so,
to.
So medical data is even worse than other data sets. Okay, I mean, this is my real world experience. Basically, we found out that they were using very primitive securities, the systems, encryption, and everything else was very primitive.
We are running out of time. We are running out of time. I think there's one more question from the Zoom. I'm going to let my partner ask here.
I have more questions.
Okay, I think maybe we talked, since we have only 6 minutes left. What we need to do is we need to have somebody from the chat box. You can write the question in the chat box, and I can read the chat box, and I can see some representative small questions. Maybe that would be faster, because most of us work in security can sometimes influence what metadata is attached to the log. Are there any way we can provide? So I'm just reading some chat box here, okay? Those of us who work in the security can sometimes influence what metadata is attached to the logs we dump into the SIEMs. Are there ways to provide better metadata that will improve results from machine learning from those logs? This is a very generic question for a very particular problem area. And I think this is domain expertise. People will answer your question about the domain that you have. I mean, so the thing is, this is very specific to the problem set that you are addressing with your AI. If you were addressing problem about the network security, then I would say, well, let's try to do these things, because in my experience, this is what I've done. As an expert in that area, maybe I can say something, right? But the general answer is very difficult. All right. Okay. All right. Now, there are lots of people who are commenting and agreeing with what I said. Are there any other questions here? Yeah,
we're running out of time. I think we need to move on. I think Ashutosh has something to present. Ashutosh, are you still online?
I just wanted to comment one more thing, Raj. I think people are talking about data. IEEE has a data code. I don't know if people have used that. That is something in the lack of data, right? I'm just thinking whether we can make use of that.
Yeah, so I must say that basically we have put our data set also there, and everybody is putting the data set, but it is really as real as our data set is. I'm just telling you that because the Google will not put their data set there, and because they make billions of dollars from their real data sets. So that's the problem. Same thing for medical data, so on and so forth. So there is a data set there, but this is the best effort, and IEEE data set probably is the area that you should look first if you are doing anything with AI.
Yeah. So I think, Raj, you have a few more questions you can answer. The lack of time. Really wanted to thank you on behalf of, ACM Baltimore chapter from around the world as well. Such a interesting and, pedagogic talk, actually. This whole 9 points that you explained, really good teaching for all of us. So on behalf of ACM Baltimore chapter, extends its appreciation to Professor Jain for delivering the invited talk at the ACM Baltimore chapter third seminar 2022. We hope you can join in future in person. I know we are still trying to get out of the hybrid mode. So with that, again, I join with my fellow colleagues from Baltimore chapter. Thank you.
Yeah, thank you so much. We're going to take a quick break for about 5 minutes, and then we can start with the second talk.